Hi everyone, I'm going to be working on the crashing question in the 2024 NHT Exam 2 paper and hope this helps. A tilt-a-whirl attraction is being upgraded. It will be closed for the duration of the upgrade. The upgrade involves 12 activities A to L. The directed network below shows the activities and their completion times in days. And so the first question says, list the activities that have exactly one immediate predecessor. So clearly, as you can see here, activity C has one predecessor, that's A. Activity D has a predecessor B. Activity E also has the same predecessor B. And J has a predecessor I. The next question is, what's the minimum number of days the tilt-a-whirl will need to be closed to complete the project? So they're asking you to do a forward scan here, and I have done it, but I will repeat it if you want. So I usually put these boxes with earliest start times and latest start times at each vertex. And I start with placing a 0 at the beginning, and then I go along the path AC. And 0 plus 5 is 5 over here, the earliest starting time for activity C. And then 5 plus 6 is 11. Now, as you see over here, I haven't placed 11 in the box here. That's simply because when you're doing a forward scan, it's good to have a good idea as to where you're going to be making the choices and choosing the larger value. Now, I have actually placed these choices here. I'm going to be making a choice here. I'm going to be making a choice here and a choice here. So when I come to an edge where I have to make a choice, a vertex, then I write the value that I get, for example, 11 at the end of the edge here. Now as I go along B, 0 plus 5 is 5. And from here, I go along activity D. So 5 plus 7 is 12. Now of these two, 11 and 12, I make a choice of choosing the larger value. And from this vertex, I can go along activity, I can continue doing activity F and come to this vertex. But here again, I'm making a choice, choosing, because after B, I can continue doing activity E. And if that is the case, I add 5 plus the duration time of activity E, which is 5, and I get 10. Whereas if I had, after C, if I'd continued with activity F, I would add 12 plus 3, 12 plus 3, and I would have got 15. Of these two activities, the larger value is 15, and so I'll choose 15 here. So then I continue to work on activity G. 15 plus 4 is 19, and I write it on this edge because it's a choice again here. And then from the end of activity C, I continue to work on activity H. So 12 plus 3 gives me 15. So of these two values, 19 and 15, I will choose 19, which is the larger value. Now 19 plus 5 is 24. And coming along I, 12 plus 14 is 16. And 16 plus 6 is 22. And again, of these two, I choose the larger value, 24. Now 24 plus 2 is 26. And that answers our question about the minimum completion time to complete this project. And then part C says, what's the latest starting time in days for activity I? Now I find it easy to answer these questions about latest starting time if I do a backward scan. So now let's practice a backward scan. Firstly, what I would like to remind you is that it helps to actually decide, just like when we were doing a forward scan, we decided, hey, I'm going to be making choices at this vertex and this vertex. It's good to decide when doing a backward scan as to which vertices we are going to be making choices. And remember, when you're doing a backward scan, you always choose the smaller value. So if you can see my little, the lines in pink, this is the place when you go backwards, you're going to be making a choice. That also is where you're going to be making a choice. And that is where you're going to be making a choice. So it's at these places that you have to be careful. So let's start the backward scan. So we always fill that box with the same time as the minimum completion time, which is 26. And then 26 take away 2 is 24. And then we can either go backwards along J or K. Let me go along J. So that's 24 take away 6. That gives me 18. And then 18 take away 4 gives me 14. Now, because I know I'm going to be making a choice here, I don't write 14 directly into this space here. I write it at the end of the edge. Now let me come along. Let me choose a thinner pencil maybe. Anyway, okay. So now let me come along K, activity K. So 24 take away 5 is 19. Now 19, so remember you're always going in the direction opposite to the direction of the arrow. 19 take away 3 is 16. Now this place is the where you're going to be making a choice. So write 16 over here. There's already 14 here. And there is one more edge before we decide what this space is going to be. So 19 take away 4 is 15. And 15 take away 3 is 12. And of these three values, 12, 16 and 14, 12 is our smallest value, and that's when we fill up the latest starting time space here. Now we continue our backward scan. We go from this point and we scan along activity E. So that's 15 take away 5. Now here again we are making choices. So I'll write 10 over here. And then 12 take away 7 is 5 here. And we choose the smaller value 5. And 5 take away 5 is 0. Remember, we're making choices here as well. And 12 take away 6 is 6. And 6 take away 5 is 1. We take the smaller value, and that's 0. So that's the forward and the backward scan. Now to answer the question that we were asked, they said, which activity has the longest float time? Now if you look carefully, activities which are not on the critical path will have a float time. So let me first indicate the critical path. Now the easiest way I have found to find the critical path is to add values, the earliest starting time, and see, so 0 plus 5 is 5. And then either I could go along E or along D, but if I add 5 plus 5, I don't get 10, I get 15 here. So obviously that's not the critical path. So I'll say 5 plus 7 is 12. And then I look at all the edges taking off from it. And I should look for the boxes where the earliest starting time is equal to the latest starting time. And then continue adding. So 12 plus 3 is 15. 15 plus 4 is 19. 19 plus 5 is 24. And 24 plus 2 is 26. So clearly, the path that I have highlighted in yellow is the critical path. Now, if you look at all the activities that are not on the critical path, they will be A, C, I, E, H, J, and one of these activities is going to have the largest float time. Now, let's look at what is the float time. Float time is calculated using a formula. You could, if I was to just explain it simply, let's take the edge E, which has a duration of 5, and the boxes at each of these, at the earliest start time is 5 here, and for the next activity, the latest start time is 15. Now, this is the latest start time minus, so latest start time minus earliest start time, which is this value, minus the duration time, which is this value. So 15 take away 5, which is here, minus duration time, which is here. So that's the usual way to calculate a formula based float time. But if you want to just pick that off from the diagram itself, after having done a backward scan, you can clearly see that the value on the edge, for example, if I take activity E, when I did a backward scan, I got 10 here along this edge. Now, the earliest starting time for that activity is 5, and the latest starting time for activity E is not this 5 here. This is the latest starting time for activity D, because we chose the smaller value. The latest starting time for activity E is this value that we got when we were doing a backward scan at the end of the edge there. And 10 take away 5 is 5 days, which gives you the float time. Now, if I was to give you another example of a similar backward scan helping you find float time, let's look at activity I. Now, activity I, you could either calculate using formula as 18 take away 12 take away 4, or you could look at the earliest start time of activity I, which is 12. The latest start time for activity I is 14, which is what we got doing the backward scan, and the difference between these two values, 2 days, is the float time for activity I. So you could adopt either method and calculate the float time. And that was E with the longest float time of 5. Now the question continues, asking you to do some crashing over here. The crashable activities were given as A, B, D, E, G, F, H, and the costs involved were given as well. And a table is given where it tells you that the reduction in completion time can be 0, 1, or 2 days, and you have to crash all these activities if possible. And they usually give you a little table which you have to fill up like I have, but then let's first see as to how this can possibly be done. The analytical method is usually the easiest method. I'll come to the other methods afterwards. So I record all the activities that can be crashed and the costs involved. On the diagram itself, I highlight the activities that can be crashed, and then I start a forward scan. Now, if I was to reduce or crash certain activities in this project, all I'm trying to do is reduce this minimum completion time without wasting money. Sorry. Now, let's look at, as I said before, we're making choices here, we're making choices here, we're making choices here, and we're making choices here. Now, let's look at path activity A and activity C. Now, A is a crashable activity, and the maximum I can crash it is, let's say, 2 days. So if I had crashed this by 2 days to A3, I would have got 3 here. This is not, C is not a crashable activity, so 3 plus 6 would be 9 here. So instead of 11, instead of 11 here, I get 9 at the end here. Now, before you decide to crash B and D, let's just first find out what would have been the value at this edge. As you can clearly see, if I hadn't crashed, it would be 12. But 12 is greater than 9, and let's try and make it equal to 9, because I can't crash 9. I can't bring down this value 9 anymore. So the difference is 3 here. And here is where costs come into the picture. B is cheaper than D. Therefore, you crash B by 2, and that makes it B3. And crash D just by 1, and that makes it D6. And when you look at these new activity durations, so 0 plus 3 is 3 instead of 5, and 3 plus 6 is 9 on this edge. So now you can see that these two being the same, the smallest value you will choose is 9. So you've reduced now, just by crashing A, B, and D, you've reduced 12 to 9. Now let's go along from this end. Let's now continue with activity F. Now F is not a crashable activity, so 9 plus 3 will now give you 12 here at the end of this edge. And E is a crashable activity, but before you crash, let's see if it needs crashing at all, because 3 plus 5, this 3 plus this 5 gives you 8. Now 8 is already less than 12, so there's no use crashing E at all. That's wasting resources. So because we're going to be choosing the larger value, which is 12. So we choose 12 here. Now we continue working with 12, and let's say we crash G by 2, and that makes it 2 here. So 12 plus 2 gives you a value 14 here. Now coming along the activity H, that is 9. This 9 plus 3 is 12 here. So don't bother crashing H, because the value 12 is already smaller than 14, and we're going to be choosing 14 anyway. So the new value, instead of 19, we will have 14 as the earliest starting time for activity K. Now, when we go along I, 9 plus 4 is 13 instead of 16, and 13 plus 6 is 19. Now let's go along K. 14 plus 5 is 19 as well. So at this point, we are going to be choosing, both being equal, we will choose 19. And 19 plus 2 is 21. So we can see that we've actually crashed 5 days, and the activities that we crashed were, let's now look at the activities that we crashed. We reduced A by 2. We reduced B by 2. We reduced D by 1. We did not touch E at all, so E by 0. And then we went along reducing G by 2. We did not touch H because we didn't need to crash it. And these are all the activities that we will be reducing. And I find this the easiest way to go about it actually. So hope this helps. I can explain the other methods in another recording. Thank you. Bye-bye.